So here we are, and it is time to talk about the number one thing which I think people struggle with JavaScript, and especially in understanding these more advanced topics and the more advanced words and buzzwords that you hear around the industry. In this video, we are finally going to cover the concept of currying, and we're also going to talk a little bit about partial application. Now, these two things are just conceptual words for implementing something with our function. So far, what we've covered is understanding higher order functions as well as function closures, and we ended up with something like this, our getNameFromID function, which we then go ahead and call, which returns us a function, and then we call it again. Now, conceptually, this is actually pretty similar to the idea of what we want to do with currying. However, currying itself is a new concept. So ignoring the code that we have already, I want to talk you through what currying actually is, because it is by far made out to be more confusing than it is. At the moment, we've got our function down here. We can ignore it for now. Now, what I want you to imagine is that we have a particular function which accepts arguments A, arguments B, and argument C. You can see that we have one function which accepts one argument, and we have one function which accepts another argument. But it's typical that in our application, we might have something like this, where we have just one function which takes the ID and the items at once. So you could almost consider that as this function here. Now, what currying allows us to do, let's say we have this const curry equals some kind of function, and we're actually going to write our own curry function momentarily. But what we would essentially do is wrap this function in a curry. So curry, in fact, is a higher order function, which simply allows us to transform our functions so that we don't need to call it as A, B, C. It means that we can call the arguments one by one. Now, it's important to remember that this is an advanced technique and it doesn't call the function, it simply transforms it when we curry something. What it would allow us to do is call our function of f and pass in the first argument of a. F would then return us a new function that we could then apply the next argument to. And this is why we've learned about closures, would return us another function where we could pass in arguments c. So in this case, this is our typical function where we call it at once and we pass in a few arguments, whereas what we would do in functional programming is curry a function like this, and it would transform it into the ability to be able to call it sequentially, one after the other. And that is simply what currying is. It's the ability to transform a function like this into being able to call like this. And you may think, why do we need to do this? And in the next video, I'm going to show you some really amazing patterns when we deal with function composition. And this is why currying in functional programming is so important to grasp. So that is, in fact, our definition for currying. We simply want to take a function that uses perhaps comma-separated arguments A, B, and C, and we want to transform it into the ability to just pass them in one by one, and each time we return a new function that applies the previous set of arguments. So what I want to do is go ahead and write out our curry function, and then we're going to watch how we can apply it to our getNameFromID functions and how it affects the rest of our program. Now, there is one thing which is very interesting with currying, is that using a curried function, so when we momentarily, what we're going to do is transform this into a curried function by wrapping it in our higher order function. But one of the special capabilities is, even though we're transforming from this syntax in our heads, in our mental model, we're transforming a function from this into the ability to call this, we can still call it the original way. So currying, in fact, allows us to take an existing function, we can curry it, and then we can call it the normal way, or we can call it the more functional way by using the currying approach. Now, what we want to do is create our curry function. We don't really have to know how this works internally. However, it's not that complicated, and it allows us to demonstrate currying very powerfully. The easiest way to grasp this is to simply build it and then have a look, and I'll explain to you exactly what we're doing. Now, inside of our curry function, we also need to return a new function. What I'm going to do is spread these arguments in, and then inside the body of this function, we can then return another function. What this simply does is take our initial function and then it applies the arguments to it later on. So what we can in fact do is return, and here we can use function.bind. If you wanted to, you could create another function. However, things do get a little bit nested. So what I would typically do is just use function.bind. Otherwise, we have to have another closure, which we can then call function.apply inside. So we don't need to really know too much more about that, but I'm just giving you some further info. We have our function bind, and we want to spread our arguments into it. Interestingly enough, that is all we need to do to actually curry a function from this syntax to this syntax. So what we can do is take our curry function name, and our get name from ID, we want to actually curry it. However, it's kind of in this curried looking setup already where we have a function which returns us another function. So what we're going to do is reset it back to that older looking style where we're not really dealing with functional programming, or at least it just looks like a normal Lambda expression. And all we're simply going to do is wrap it in the word curry. This is then going to transform it into a curried function. This allows us to now compose and write our functions in what we would call a normal functional style. So we just have an ID, we have the items, things are super readable. I can come into the code base, I can say, yep, I'm expecting some kind of array. I want to use find. We get the ID. Oh yeah, brilliant. Yep, the ID comes through the arguments, and then we're looking for that .name. But using curry transforms the function for us. So instead of doing something like get name from ID, where we could pass in the ID and then the array, we can actually call things separately. And if you haven't noticed this, we're actually using the curried function, and it's working perfectly out of the box for us. How do we know this? Because we have our two console logs here. So we're in fact currying this initial function, our get name from ID, and you can see that we are actually expecting the ID and the items to be passed in at once. But you can see here that we are absolutely not doing that. We are not taking these items and passing them in here. However, that doesn't mean that we cannot do that, because currying does, or at least should, allow us to do exactly this. So before we go any further, what I want to do is adjust our curry function to allow us to also call it like this, because at the moment what we're doing is essentially currying our function. And we can demonstrate this a bit easier if we were to do something like this. So what I'm going to do is just get rid of our logs where we're actually calling the function, and I want to just call the results of the function. So our get name from ID, we're taking our fries, we're passing in the items, and then the second function, we're passing in our burger, and then we're passing in the items, but this is in a separate function call. So our first function call is going to return us a new function, which when we then call it, is set up to receive the arguments from the first function. So it then passes them into this and calls them both at the same time. So really, this function call here isn't executing this piece of code entirely. It's executing our curried function, which is almost caching the function in the closure. And then when the closure returns and we call it again, it's then taking that initial function and it's binding it for us with our arguments, which would be our items. What we want to do, because if I hit save now, we're actually going to see an error in the console. You see we have a function instead of our get fries. So get fries is on line 23, but this isn't actually working. So the idea, and I mentioned this earlier, is that currying should allow us to call the function in the normal way, as well as the curried, more functional programming style. At the moment, our curry function doesn't support this, so let's go ahead and add this. To do this, we can say if the argument.length, because our args, we're using a spread, so here we're actually going to have an array, we can say is greater than or equal to the function.length. What I want to do is just have a look at this quickly. So we can say console log, and we can log out that function.length. We'll also log the args.length just as a comparison. So you can see that we have 2 and 2, which means that we are using this function. If we were to comment this out and comment the log out, we wouldn't actually see anything appear. So we know that by calling the function normally, it's going to execute this first block because the argument's length is, in fact, greater than or equal to the function's length. So here we have a match of 2 and 2 because we have 2 arguments that are being passed in as 1. Now instead of returning function.bind, because we're calling the function normally, all we want to do is simply execute it. So here I'm just going to use function apply, we're going to pass in null, and we can then pass in our args. It's important to note that function.bind expects something like this, where we have the context, which we are specifying as null. You can see here that we have the this argument, and then we have a list of arguments to be passed in to the new function. So what this would actually mean is we have to comma separate all of our function arguments, which is why we are taking our args array and then spreading it in to comma separate them. Now with function apply, if we were to move this up and just rename it, apply expects an array. So here we can just pass in our args array as if it were like this. So that's why we're using the spread here and we're not using the spread here. The main difference between function apply and function bind is going to return us a new function which will have the context and the arguments bound to it, whereas function apply is going to execute the function pretty much as if we were to do something like this. That's pretty much exactly what it's doing. However, by using apply, we're explicitly setting the this value of the function to null. So now when we save this out, you can see that we have our jumbo fries and we also have our super burger. But there is a massive difference between how the functions are actually executing. Yes, they both achieve exactly the same thing. However, this is being called in the normal fashion, and our getNameFromID, the second function call, has been curried, and we are then sequentially passing in those function arguments. And it might be that we have more arguments and more arguments and more arguments, and our curried function will just continue as is. Of course, for each argument, we would need another argument to be accepted in here as well. Now, I also want to talk about this concept of partial application, which is a common thing that we will be using with functional programming. Earlier, what we in fact did was have this items, and it was inside of here. So we were in fact using our getNameFromID, which is pretty much acting as our higher order function. But what we're doing is we're calling a curried function. And because we're only applying that function rather than executing it immediately, such as like this means that we are partially applying the function. So when we talk about partial application, it simply means that we are partially applying part of our curried function. So it's a more confusing term than it actually is, and I think you'll agree that really it's just a higher order function here that we are then partially applying. Now we can also demonstrate that if we remove our curried function, everything in our application will then blow up. We could of course remove our curried function so we don't see any console errors. And you then have uncaught type error, cannot read property, find of undefined. So what's happening here is this line of code is passing in our ID, but we're actually leaving off the items array because we're trying to call it an items does not exist yet. By introducing back our curry, we then can pass in our ID, and under the hood, our curry function is automatically creating that new function closure. By returning a new function, it's taking our args and passing them into a new bound function, which we can then partially apply and then call later on. Now this concept and why we are breaking things down in currying to this extent is because this is really, really important to grasp with functional programming. I think you'll agree in the next few videos when we take this concept of currying to the next level, we can really improve your skills there. We're going to be discussing function composition, and currying is perhaps the most powerful thing for us to use daily with our functional programming knowledge. We're going to be dealing with function composition, we're going to be dealing with function pipes, and all of them come down to understanding this currying concept. If you want to skip to the next video, feel free, but I'm just going to do a quick recap if you want a slight jogging of your memory. So at the beginning, we talked about a function, a normal function. It could be from anywhere in a code base. It could be a third-party library. It doesn't matter. We can curry any function, and that is the power of JavaScript. What I'm going to do actually while we're here is just shorten this because we can make it look even nicer with an ES6 arrow function. So we have a nice function which returns a function, and then we simply write all our logic inside one body of the function. So this looks nice and neat. Back to where we were, we have this function which we can transform into the ability to sequentially call each argument one by one. That's all it is. If you think of this A as ID, B is going to be items. If we did have C, for example, it would be C as well. So for each function call, we need to pass in a new argument, and this is a very heavily used pattern in functional programming, which we'll explore next. Now, I did say that we don't really need to worry about the implementation details of a curry function. If perhaps you're using a functional programming library, this will usually come out of the box for you in libraries such as Ramda or Lodash, for example. But really, this is pretty much all you need to have a really nice, robust curry function that abides by the rules of currying, where we can still call a curried function the normal way. So that was pretty much the check that we added. If the argument's lengths are greater or equal to the function length, then we just simply want to call the function normally, as we've done here. We've then talked about partial application through returning a function which is bound with a new context and passed in any of those arguments that we've passed in up front. By calling it just here, we are then partially applying the function, and you can see that we're just logging out the result here, whereas our getBurgers returns a function that we can then call again. So I absolutely love this. This is a superb topic in functional programming, and this is just the beginning. So make sure you've understood this video, maybe go through it a few times if you need to. But otherwise, I will see you in the next set of videos where we're going to take this up a notch.